In this video, I am going to solve this problem on particle equilibrium involving three-dimensional forces. What we have here is a rectangular plate which is in equilibrium in a horizontal plane, and it is supported by three cables AB, AC and AD, and one end of the cables is tied to this hook, and the hook in turn is supported by another cable, and the upper end of which is perhaps connected to the ceiling or a crane. The tension in this cable AC is given to be 60 newtons, and we have to find the weight of this plate. Let's assume the weight of the plate is W newtons, and the first step in solving such problems is to draw a FBD, and here we have a choice. Either we can draw a FBD of the hook or the rectangular plate itself. The FBD of the hook will look like this. What you see here are four forces acting on the hook. These are the forces acting on the hook because of the tension in the cables, and this force W is the force acting on the hook in vertical direction because of the tension in the cable, in the upper cable, right? So as I said before, there are four forces acting at point A, and our task now is to write all these four forces in vector form. W is acting upwards, therefore it is the magnitude of W times J. The force TAB is equal to the magnitude of TAB times a unit vector along AB, and the unit vector along AB is the position vector divided by the magnitude of the position vector AB. And to figure out the position vector AB, we have to travel from A to B, and we go 480 mm in minus y direction, 360 mm in positive z direction, and 320 mm in minus x direction. So we get minus 320I minus 480j plus 360k, and this is the magnitude of this position vector, and this will get simplified to the magnitude of TAB which multiplied by this vector. Likewise, we determine the force TAC, and that will be equal to magnitude of TAC times unit vector along AC, and for determining the unit vector AC we have to travel from A to C, and we go 480 mm in minus y direction, we go 450 mm in positive x direction, and 360 mm in positive z direction. So we get 450I minus 480j plus 360k, and the denominator is the magnitude of this position vector. We know the magnitude of this force TAC, it is given to be 60 newtons, so it will be 60 times this vector. And likewise we write the force TAD in vector form, and that will be equal to its magnitude times unit vector along AD. To determine AD, we go again 480 mm in minus y direction, we go 360 mm in minus z direction, and 250 mm in positive x direction. So we get 250I minus 480j minus 360k, and the denominator is the magnitude of this position vector, and this will simplify to this vector, right? And now we have all the four vectors in vector form, and now we are ready to do summation of them and equate it to 0 for equilibrium. Because all these four forces are concurrent forces, our equilibrium condition is just a single vector equation, sigma f equal to 0, and this is equivalent to saying that sum of x component of all the forces is equal to 0. Sum of forces in y and z direction will also be equal to 0. So let us take up the first equation, and to write this equation we pick all the I coefficients from all these four forces, sum them up and equate it to 0. Here it is TAB times minus 0.47, which is this term here. In this force we have I coefficient as 60 times 0.60, it is here, and in the last force it is TAD times 0.38, which is this term, and all the sum of all these three components will be equal to 0. In the next equation, we have four terms. So we pick J components from all the equations, sum them up, and equate it to 0. So we get this equation. And likewise, when we pick the K components and sum them up and equate it to 0, we get this equation. So now we have three equations, and notice that in the second equation, we have three unknowns, W, TAD, and TAB, while in the first and third, we just have two unknowns, TAB and TAD. So we have a set of simultaneous equations which can be solved to get TAB and TAD. So TAB will work out to 538 newtons and TAD will work out to 571 newtons. And now we plug in the values of TAB and TAD, the second equation, and the magnitude of W works out to 843 newtons. So this is our answer. And we are done. So thanks for watching, and in case you have any question, please leave them in the comment section below and I'll be glad to answer them. If you have liked the video, please like and share, and do not forget to subscribe to the channel. So thanks for watching again, and see you next time.